Okay, guys, day 3 of online learning. In order to answer this question, we need to look carefully at our x and our y axis, so what each of the graphs are measuring. So students were given data for 2 reactions, which they're calling reaction number 33 and reaction number 15. So from the graphs below, we want to determine the rate order. So is it 0, first, or second? Explain your choices and then rate the integrated rate law that would be used. So when I look at the first graph, I'm looking at a concentration versus time graph. Now, if this were a straight line, so if it went like this for either of them, we would know that it's a 0 order. But since it doesn't, that gets rid of 0 order. So we know neither of them are 0 order reactions. Next, we're going to look at the natural log of concentration versus time. And we see, okay, we do have a straight line here. So that tells us when we look at natural log of concentration versus time that this is a first order. So reaction 15 is a first order reaction. So the form of the integrated rate law that we're going to use is the natural log of A at any given time is equal to negative k, because our slope is negative, times the time. So this is our y equals mx, and then plus where it intercepts initially. So the natural log of our concentration initially. Okay. The next one I see is 1 over the concentration versus time, and I also see a straight line. So that tells me that this is a second order reaction. And a second order reaction, the integrated rate law that we use, is going to be 1 over the concentration at any given time, so anywhere on the line, is equal to, so that's our y, equals mx. So m is going to be k because it's positive, x is our time, and then our intercept is going to be the 1 over our initial concentration, which may be 0, but it might not be either. It might not come right out of that corner. Okay, so this question is really about, like, do you know what the graphs tell you? So make sure that you can explain why each of those graphs demonstrate that it either wasn't that type of reaction order or that it was, and then also that you can determine the integrated rate laws, and then also that eventually you can plug numbers into them. Again, this is kind of a straight off an AP test type question, so this is definitely something you might see on your AP test.